My name's Toby Bellwood. I'm the product lead for Lagoon at Amazy.io. I'm not based in New Zealand, unfortunately, but I am based in Canberra, Australia. And Amazy.io has quite an extensive team all around the world, but we're particularly proud of our New Zealand and Australia teams. We've got 8 people now between Australia and New Zealand, and we do an awful lot of we've got an awful lot of work down here, so we view ourselves as having sort of 2 homes. So I apologize for not being a true New Zealander, but I am in heart and spirit. So yeah, we'll be talking a little bit about Kubernetes, a little bit about Lagoon, a little bit about Amazy.io, but as I said before, more than welcome to sort of take questions. If you want to try and interrupt my flow, go for it. I'm more than happy to do that. Either ask a question in the chat or unmute yourself and butt in. I'm happy either way. So quickly, I'll go through Amazy.io. Amazy.io is a global managed service provider, delivering secure enterprise-grade web ops solutions and services. And Amazy.io's key platform is Lagoon. It's a product called Lagoon, and it's specifically built for Kubernetes-based modern cloud environments. The company itself, we sort of pride ourselves on being able to host anything anywhere in the world. So we deal with a number of infrastructure providers, vendors. Our team is based all across the world. So Australia, New Zealand, Europe, South Africa, North America. We've even got a presence in the Caribbean. So I'm not sure that was business driven, but he sends us lots of photos and we're very jealous. We pride ourselves on our 24-hour a day chat-based support. So because we're a global company, because we've got people all around the world, we do support our customers all over. Everything is open source. We believe strongly in open source. So Lagoon product itself is open source. A lot of the products we use inside Lagoon are open source. And we think for our customers and our users, having full visibility into what we've built and what we're doing is the only way to go. So we're fully committed to transparency. Globally, clients include governments, healthcare, financial services, education, media, travel, you name it, we've pretty much covered it. And we've worked really hard on being trusted for our security and our support. And in the last few months, we've also launched a partnership model to bring ourselves a lot closer to the people who are running sites on our platform and people who are working with their customers. So yeah, we believe strongly in that collaboration, cooperation. So I'll quickly, from the top, I'll just quickly go through what Kubernetes is. For anybody that doesn't understand what Kubernetes is, this will be a very quick intro. For anyone who does understand Kubernetes, I apologize if I've missed anything. But basically, it's a portable open source platform for containerized workloads and facilitates declarative configuration automation. So basically, the platform itself is all defined in code. So everything you do in Kubernetes is written down as a piece of code. So you have to write every element you want to build in Kubernetes. You write in code. It's not pointy clicky, draggy droppy like some of the systems of old. It gives you a lot of flexibility. It's a natural successor to virtualized environments. So in the old days, we used to have 1 server per site or 1 server per web presence. We then went to virtualize, so 1 server could host multiple VMs and each VM could do multiple workloads. Kubernetes and containers are the natural successors of that. So they can be, you can have really, really tiny sites or applications that only serve a static page and receive 500 hits a month, up to sites that host millions and billions of page views and can scale off the charts. Sean Hamlin, one of our technical account managers, did a really good talk yesterday about the need to scale during the COVID-19 response for the Australian government. So there should be a recording somewhere around, but if you can dig that out, that's a really good example of what Kubernetes can do and how it can scale massively in a way that virtualized servers couldn't, and in a way that physical servers definitely couldn't. It's used all around the world. Everyone's talking about Kubernetes. Everyone wants Kubernetes. it is not for the faint of heart. It's not something that's easy and straightforward to deploy. We at Amazing.io, we're a very big Drupal, very big part of the Drupal community, and there's a brilliant Slack channel in the Drupal chat called Kubernetes, in which almost every month someone steps in and says, hey, I'm trying to deploy my site to Kubernetes and I've come across this error. And there's sort of a collective sigh as everyone realizes that we've been doing this for 2, 3, 4, 5 years, and we understand the nuances, and someone coming in cold trying to deploy particularly a CMS application into Kubernetes is in for a whole world of learning. It's a fairly comprehensive undertaking. All the examples you see of Kubernetes will be how to deploy a little Node app or a little Python app, or real world implementations are far harder and far more complicated. So Kubernetes, as I alluded to, it's based on containers. So if you're familiar with Docker, Docker has this model of building applications from containers. Each container has a specified purpose, and those containers can interact with each other so you'd have a database container, and you'd have a web application container, and if you've got search, you'd have a search container. So these containers, they're called pods, and they sort of host these individual components of the applications. Kubernetes has deployments and sets, which tell Kubernetes how to deploy these pods. So what ports should they open, if they, how many of them there should be, whether they should tear them down when they die, whether they should recreate them, how much resources to give them. And there's a whole raft of things. On the right-hand side, you can see a very small part of what a Kubernetes deployment looks like. Rolling updates, unavailable, surge, replicas, templates, there's ready seconds, and there's a whole lot of information there. It's really, really controllable, but it's really hard to get right. Services. So if your application needs connecting to the outside world, so whether that's a web service or whether that's a database service or whether that's a search service, Kubernetes controls all of those. So it knows what ports to open, it knows what external endpoints to give them, what web domains, etc. Storage. Every application needs, well, most applications need to store stuff somewhere. Where do you store that data? What kind of storage is it? If you've got an application that has multiple pods because we've got massive traffic, you've got lots of replicas, you've got to have a way that that storage can be accessed by multiple people at the same time. So you might need multiple different pods writing to storage at the same time. So you might need to make that read write many, read writes once if you've only got a single writing stream. Whereabouts does that go? What kind of storage? And how does that interface with the underlying provider? Kubernetes has jobs. A job is just a short running task. It's not necessarily a website. It's more a cron job or something small that you need, particularly in the CMS world. Drupal, WordPress, Laravel, they all have short running tasks that can be used a little bit of gardening, a little bit of tidy up behind the scenes. And labels. Kubernetes has a lot of labels, and labels are what's used to control all manner of things. They've also got annotations, which can help Kubernetes decide where it puts things. A Kubernetes install has multiple nodes, and each node can have a certain amount of pods, and those pods can go on nodes depending on. What I'm trying to get at is that Kubernetes, it's really hard. There's a lot to understand, and it's a very different mental model. Each of these applications that we build then live inside an individual namespace. So a pod from one namespace, pod from your website can't talk to someone else's website unless you specifically allow it. There's a lot to get your head around. And coming from a simple, if you've got a simple web application, LAMP stack, if you're used to using Apache, MySQL, PHP, it's very different. It's very different because you don't have direct access, you don't have direct control to a lot of the environments that are running. You can't just go in and make a change to a production file. The production file's got to be deployed via one of those deployments. you can make a change, but the next time a deployment comes through, it will overwrite whatever change you've made. So you've got to put that change back through the process. Application delivery in Kubernetes is something that we have identified as being something that Lagoon can solve. So as we've just covered, we're talking about pods, we're talking about deployments, we're talking about storage. There's a lot of configuration needed to just run an application. And that's without any of the extras that you'd want to run in production. So yeah, when we're talking about storage, talking about ingress, we're talking about strategies, we're talking about replicas, we're talking about resource allocations. There's an awful lot that you need to do. And web applications naturally are very complex. If we're looking at a typical Drupal installation, you might have a PHP process, you might have an Nginx to serve the site, you'd have a MariaDB or MySQL or Postgres database. You might have Solr or Elasticsearch. You might have Redis to do caching. You might have Memcache. You might have Varnish. You could have like easily 7 or 8 different services inside those applications. And each of those services need all of that configuration. They need to be configured to talk to each other. They need to be configured. You generally don't scale your database the same way you'd scale your web in Kubernetes. And if you have, Kubernetes is built to be disaster tolerant, it's supposed to be fault redundant. So a node that has pods in it, if that node becomes unavailable or non-responsive, those pods can automatically schedule somewhere else. Your application has to be able to handle that pod scheduling on a different node. There may be a few seconds where Kubernetes has to work to find out where that pod's gone to. So your application has to be that little bit tolerant of that. In order to do all this, your developers need to know a lot about YAML. And for those that don't know a lot about YAML, don't. It's horrible. It's like JSON, but made complicated for reasons, we'll say. But yeah, the slightest error in a YAML format can cause things to not deploy in unintended circumstances, etc. There's a few UIs for managing a Kubernetes cluster, but not many for doing the sort of the configuration aspect of Kubernetes. A lot of it, you're in Notepad, you're in Visual Studio, you're editing YAML, or if you're brave, editing YAML directly in the Kubernetes UI. And while Kubernetes knows about these strategies, rolling strategies, it knows about the pod failover, it knows about the redundancy aspects, this isn't automated out of the box. You still need to program and configure your applications to do this. And also, the base images for applications are often very customized. So Drupal has custom elements inside it that it needs to have on top of PHP to work. WordPress has similar. I know Silverstripe in New Zealand does similar. There need to be a couple of extensions enabled, and there's sort of no real broad standard about how to do that. Kubernetes doesn't come out of the box with this stuff. It's something that you need to build, you need to configure yourself. And there are a lot of tools out there for anybody that's ever looked at the Cloud Native Compute Foundation's landscape, the CNCF landscape. You'll see there's an awful lot of tools around application delivery, around continuous delivery. And we've looked at them. I've got a super spreadsheet with about 100 tools on it at this stage that we regularly look through and try to identify what are they doing, how are they doing it. The primary focus of a lot of these tools is for the deployment of a single site. So if you've got an application that you want to build and configure to put on the web, if it's a single app, you can use Flux, Argo, Tecton, Waypoint. There's almost a new tool every week that comes out. These are really good for individual applications where your DevOps team knows that app and it can make those changes. As soon as you want to deploy more applications, you've got to build an individual pipeline for every single application you deploy. For our point of view at Amaze.io, as a managed hosting provider, we host thousands of sites. And managing thousands of pipelines for thousands of sites is a huge burden. And while we could template some of it, we've gone a different route, and we're really trying to sort of tailor application delivery to web applications and really look at what are the web applications most commonly in use. And that's why we've decided that a lot of the sensible defaults that come out of Kubernetes aren't the best for what we're particularly doing. So we're looking to add and augment those defaults with the settings that are best for our particular applications. And the other aspect that comes to this is that once you've got your application running on Kubernetes, it comes with a bit of sort of infrastructure monitoring, but it doesn't come with application monitoring. It doesn't come with logging. So if you need to collect logs, with application logs or container logs or administration logs, if you need to do backups, you're sort of raw backupping a Kubernetes object. So one of the things we've wrapped into, as well as adapting those sensible defaults, is we've put in what we think is the optimal monitoring, logging, and backup stack for web applications. So enter Lagoon. We like to think that Lagoon drastically reduces the time taken to bring web applications to Kubernetes. So we'll provide that configuration tooling insights, and we've got a lot of experience running these sites in production at scale securely. So Lagoon is developer focused. The idea is we put the power back in the developer's hand. So not having to write Kubernetes YAML if you're a Drupal or a WordPress or a Silverstripe dev is going to be one less thing to worry about. I know that a lot of our team here at Amazing.io have spent a year, 2 years getting to grips with Kubernetes. And this is all day, every day. This is their job. And we learn and discover and understand stuff every day. So having to learn Kubernetes YAML on top of your job as a Drupal developer or WordPress developer is a pretty big ask. One of the things we really pride ourselves on, and that's because we're using that containerization method popularized by Docker, local development runs using those same base images that Kubernetes does. So you can do an awful lot of development work locally and be really confident that it's going to work in production as it does on your local. We've really worked to emulate, to really streamline that local to production workflow for our developers to give them the confidence in that process. It's all based on GitOps and infrastructure as code, so the same as Kubernetes, but we've brought it down to the application level. So fundamentally, all you need to do to make an application run on Lagoon is add a couple of files and a couple of lines of configuration, and it will do the rest. Obviously, because we want to be configurable, we do have options to control routes and to control storage and to control some of those jobs. But broadly, what's in the code base is what's in Lagoon. So we've got a user interface, so we can trigger those. So people who aren't familiar with command line interfaces, who haven't maybe got the permissions on the Git repo, but as a project manager or as a product owner, you can trigger a redeployment. You can see how that has worked straight from the UI. Because it's based on GitOps, when you've got PRs, you've got Git branches, we can generate automated environments from those. So if you're doing a new piece of work on a new section of your website, you can submit that as a pull request to your repo, and Lagoon will see that pull request and it will create a branch for you separate to your main one that you can then go through and you can look at and you can share with the client or the customer or the executive or your family member if you're proud, and really show them what it looks like. And that, because that's running in Lagoon, that's as close to production as you'll get. So you can really iron out any last minute kinks at that stage, and that all comes automatically generated as part of the GitOps pipeline. The UI has got a large amount of the same functionality as the API and the CLI do. So you're able to see your deployments, you're able to see your environments, you're able to delete environments. You can get a rich understanding of the current state of where your application is at without having to dig into the code, without having to go deep. And part of what we do as Lagoon is provide some of those base images I was talking about. So if you want to run a PHP web application, we've made a Docker image for PHP that's optimized towards running in Docker and Kubernetes, that's optimized to running in production securely. And the sites on our platform don't have to use our base images, but well over 95% of them do, because they've got that tooling, they've got that configuration built in, the how to send mail, how to configure robot headers, how to automate some tasks, how to set up cron jobs. So we've put a lot of thought and knowledge into those base images to be able to automate the deployment process. I'll pick up quickly that question from Rodney. How much Lagoon is our product and how much of it is packaging open source Kubernetes tools? So in terms of Rancher, we sit in a slightly different space to Rancher. Rancher broadly is used to automate the clusters, whereas we're automating the deployments into the clusters. So we do actually use Rancher to manage our clusters, but we use Lagoon to manage the deployments within the clusters. We do stand on the shoulders of a lot of open source tools. So we use a Kubernetes backup tool called K8up. We use projects like Scopio. We use Elasticsearch. We use Grafana, Prometheus. So I'll read the next part of your question. When we talk about being a managed service provider, are we meaning for off-the-shelf apps or for customers that are bringing their own applications? Broadly, our strong preference is for sort of running off-the-shelf apps. If you're bringing your own application to Kubernetes that's got your own sort of infrastructure setup and configuration, that sort of it's going to be quite hard to massage that into the Lagoon model. The Lagoon model is loosely opinionated, we'll say, towards that sort of traditional web application structure, the non-cloud native one. If you can architect your application itself to be cloud native from day one, you're going to have a better experience in Kubernetes. But as we went through, a lot of these web apps we're talking about aren't cloud native configurable.
Right. Yeah. Sorry, Toby, I'll just cut to the chase here. You know, we have a containerized application that does run under Kubernetes. I'm just wondering, when you talk about being a managed service provider, whether you are actually providing that option. Maybe this is a conversation I'd be better to pick up later with you guys, because it might not be fitting the mainstream of what you're going through today.
Yeah.
So thanks anyway.
It's kind of similar. It's on a similar line. But yeah, I think once you're looking at the kind of application I think you're talking about, and without seeing it, I'd find it hard to know. But we're trying to simplify Kubernetes for web application developers. And if you've already got a DevOps process, like certainly I'd like to have a look and see. We can sort of tell quite quickly whether we're going to be a benefit or not.
Let's pick it up offline. I don't want to divert you from the mainstream of your talk.
That's right. So yeah, essentially, we provide a similar function. There's a number of tools out there that can do something similar. Where we've targeted is the market that needs a bit of help sort of to cross that divide. And we are also capable of running and managing. Lagoon works on multiple Kubernetes clusters. We've got dozens of them from an Amaze.io point of view, so we can sort of split and segregate workloads. So in a Kubernetes stack, basically, we've got the underlying providers. So we've got AWS, Google Cloud, Azure. In New Zealand, we've also got Catalyst Cloud. We've got a partnership onshore in New Zealand with Catalyst. We can also deal with on-premise Kubernetes clusters. So the Kubernetes sits on top of that infrastructure, and we're using the managed Kubernetes services from all of them. So the infrastructure provisioning, comes as part of the AWS Google Cloud. So we're not having to install our own operating systems. We're not having to maintain patch levels and stuff like that. That all comes out of the box. So Kubernetes is there. Lagoon sits on top of that Kubernetes, and then running on Lagoon, you've got these sort of languages, so PHP, Node, Python, and we've got the applications that then sit on top of there. So Drupal, WordPress, Laravel, Silverstripe, etc., all sit on top of those applications, also on top of those languages. So yeah, strongly focused on web applications such as CMSs, because those CMSs are a little bit more confusing, but we would have a look at containerized applications. And yeah, as I said, we can sort of quite quickly judge whether it's going to be a good fit for Lagoon or not, depending on how much control basically the application wants and needs over the infrastructure. So the only requirement essentially is Kubernetes to run Lagoon. So yeah, we've got it tested and running on all of those clusters around the world. We've built a large collection of templates for Drupal, WordPress, Laravel, and Silverstripe. On Silverstripe particularly, Tom is going to give a talk on Silverstripe on Lagoon on Friday, I think. And that's the process we went through to convert a Silverstripe install to work on Lagoon, because essentially Silverstripe is PHP, Nginx, and MySQL. So it fits that mold quite nicely. One of the extra values in here is that Lagoon manages the database, the cache, and that logging that we spoke about. From a database point of view, the major cloud providers all provide managed databases. So whether it's Aurora or RDS, whether it's Cloud SQL, or whatever the Azure version is called, we've built tools that can interface with those managed databases as services. So if your project requires MySQL, requires Postgres, we can run that in a Docker container on your local machine, but Lagoon will take that, and instead of running a Postgres container in production, Lagoon will convert that to being a table in a database as a service offering. So you get the large scalability, you get the performance, and it makes it a lot more manageable from our point of view, because database scaling is one of the hardest things to do in Kubernetes. So we've basically put a layer in there that will help be able to run those at scale for you. Caching, again, we can interface with Elasticache or whatever the version for Google and Azure are. We can provision tables and entries inside there, so we can run Redis caches. Logs, so the Lagoon installs run by Mazie.io all have Open Distro for Elasticsearch running and Kibana, and we can ship logs to there, but we've also got plugins to be able to ship logs to anywhere else. So Datadog, Sumo Logic, Splunk. We've built a logging system that can put the logs that you want where you need them to be. And yeah, as I covered in the slide before, we provide those base images. We would strongly encourage people to use them if they're running a application on Lagoon, because they've got a lot of the configuration built in there already and the sensible defaults. But there's a lot of people that use our base images outside of Lagoon because we've got a rigorous process behind releasing them. We've got a lot of experience in making them and in running these kind of applications. So Lagoon has been around for a surprisingly long time. Lagoon 0 was launched in December 2016 because someone needed to run a node application in OpenShift. About 8-9 months later, Lagoon 0.5 was released, and that's where it was released publicly. That's when the decision was made to make Lagoon an open source project. A lot of work went in between August 27, 2019 and over in Australia, the Australian government, federal government and the government of Victoria made a lot of investment into Lagoon. Lagoon 1 included a full RBAC support, so role-based access control. So users and customers can really easily control what permissions their users have, what their users are available to do in the application itself. So you can give fine granular permissions to people. Last year, April 2020, Kubernetes support came. You'll see initially that Lagoon worked on OpenShift. OpenShift is Red Hat's implementation of Kubernetes. We went with native Kubernetes support just over a year ago, and that was a lot of our customers were looking for that real managed Kubernetes option. So being able to run on Azure Kubernetes Service or Elastic Kubernetes or Google Kubernetes Engine. Having the abstraction of OpenShift in there for some of our customers who had existing Kubernetes installs or existing relationships, it was really important to them. And we've taken that one step further. And there's a little tilde, May 2021, Lagoon 2. Lagoon 2 has basically been re-architected to run natively on Kubernetes. So Lagoon itself runs in Kubernetes, which means that people who are wanting to build and deploy their own Lagoon, and we now have a number of customers we're working with who are deploying their own Lagoons, managing themselves, has really facilitated that. And it's a lot easier and simpler to deploy a Lagoon on Kubernetes now than it was before. Token architecture slide, because I wouldn't feel I was being authentic if I didn't have at least some confusing looking slide with arrows and pictures all over the place. But basically, as we've said, the developer pushes code to Git. Git tells Lagoon about this code push. Lagoon tells a Kubernetes cluster that there's something to do, that we've got to do a build. So Lagoon goes ahead, checks out that Git repo, looks through it, works out what services it needs, pulls those images, builds those images, looks at what deployments, what services, what storage, what databases it needs, configures the logging, sets up backup, sets up security. If you've got additional jobs or tasks to run, Lagoon will do that in this stage. We'll watch the build going through, and once the build is ready, the cluster will tell Lagoon that, yep, that build's ready, it's good to go, and the developer gets a Slack message or an email or a Microsoft Teams or a notification that says, hey, your site's deployed, you're good to go. It's a lot more complex than that, obviously, but that gives an idea of, you basically, as a developer, you push the code and Lagoon does the rest. When it comes back to you, the notification comes back and says, hey, your site's been deployed. Hopefully your site's been deployed successfully. If it hasn't, Lagoon will provide you with logs that should provide an understanding of what's gone wrong. And 90% of the time, the problem is with the application itself, that a Drush config import hasn't worked, or some WordPress startup process hasn't worked. But because it's Git, you can check out that code and you can deploy it yourself locally, and you can try and replicate the problem. And most of the time it does. Those problems are replicatable. If not, Slack support is there to try and help people over this. One of our strongest things that we think Lagoon is really good for is portfolio management. So although Lagoon was built to run a single site, it's capable of managing multiple sites. So from some of our customers have one site, some of our customers have hundreds. We think one of the things that's really that we really like about Lagoon, and we've worked on with our users, is trying to get easy to understand intelligence about your site. So what are your sites doing? How are they looking? How are they running? If you're running multiple Drupal sites, what version of Drupal are they running? If you're running Drupal, Laravel, WordPress sites, can you easily tell which one's which? And what kind of information can we collect about those? So can we collect the version information? Obviously, how can we use that? And part of the work we're doing at the moment is around making it easier to surface that kind of information. If there's a vulnerability announced in a certain module or a certain package, how do we find out about that? one of the things that Lagoon does is integrate with image scanning tool. So Trivy, for example, is a Docker image scanner, and that can scan a Docker image, and it can pull out all the components in there, and it can identify which ones have security vulnerabilities. And that information can come straight out of Trivy and go into Lagoon. So a Lagoon user will be able to see, hey, there's a critical vulnerability with this package. I wonder where that's come from. How do I fix that? And they can then understand that that's something that needs to be remedied. If there's a Drupal vulnerability, being able to alert someone that the version of Drupal they're running is compromised. Having a task system is another thing we're working on. So having this really extensible task system. So when you're doing routine tasks, and it could be clearing your caches, or it could be doing a database dump, or it could be synchronizing a database between a production and a development environment, or the other way around. Having a task system that can do that kind of work for you without you having to manually SSH into a remote server and dump a database to your local and then push it back up to the remote and hope everything works. We've built this kind of functionality into Lagoon so that you can do that kind of work in Lagoon itself. So we'd spoke about facts. There's the ability to add metadata to projects. So if you've got a way of classifying projects or a way you need to record additional information about them, we can do that. We can collect those problems and vulnerabilities from a number of sources. And it works across frameworks. So it's not just PHP and Drupal. It could be Python and Django. It could be Node and Express. It could be Gatsby. It could be Ghost. It could be Silverstripe. It could be any one of a number of things. We're trying to build a tool that can really deploy anything. Continuous development is something that we're really proud of in our team. We do a lot of work with our customers, building features our customers want. A lot of people in our team are former customers. So we've also got a fairly strong insight into what we wanted and how we used the tool and the product. But yeah, we do a lot of work with our existing customers to take feedback on features, to seek and solicit UX research. And a number of our customers, because it's an open source project, have identified opportunities to add additional functionality, add additional features. Someone the other day picked up that the creator data of an SSH key is incorrect in our UI, found out where it is and submitted us a pull request to fix the SSH key display date in our UI. And that's brilliant. That's the kind of relationship that we want with our customers. In the wild, so I think I've already said that Lagoon powers all of the Amazy.io websites. From Amazy.io, that's over 2,000 production environments, 5,000 development environments. There's about 2,500 developers developing sites built on Lagoon on Amazy.io. We're doing almost 1,000 deployments a day. It's probably slightly more than that at the moment, but these are across our 40-something clusters all over the globe. So there's a fair amount of use of this tool in the wild. And yeah, as I said, there's 2 or 3 other customers who are running their own websites and their own hosting platforms using Lagoon separate to Amazy.io, and they're part of our community and they've helped contribute towards the product as well. We're strongly open source. So yeah, we use a number of other cloud native tools under the hood. So yeah, Helm, FluentD, Grafana, Open Policy Agent, K8up. It is exclusively open source tools that make up a Lagoon install. We do, as I said, integrate with a few other non-open source. So when we're talking about Splunk or Datadog for logging, but the primary concept of Lagoon is that it's all open source. So we've made a commitment to donate Lagoon to the Cloud Native Compute Foundation as a sandbox product. So we've got a dedicated product lead and team building and developing Lagoon. Amazy.io is going to help do the marketing. And yeah, we're working with non-Amazy.io organizations on making it a bigger, broader open source thing. So briefly, up ahead, we're going to do more on the sandbox process. We're going to because Lagoon was released 4 years ago, it makes it a little harder to untwine from Amaze.io. There's still a lot of Amaze.io defaults in it, but that's a process we're going through. So Lagoon will be standing up as a standalone product with its own website, socials, etc. But Amaze.io is still the strong #1 supporter of Lagoon and will be continuing to provide the bulk of the developer work for the foreseeable future, so that we can go through that sandbox process. We're always looking at expanding the application. So whilst a lot of our examples have been talking about Drupal and WordPress and Laravel, we are looking to push into other applications. We've got some work on CCAN, the data management system. We've got a bit more work in the Python space that some customers are looking for us to do. So to build out that set of templates so that people can build and deploy their applications using our sensible defaults more simply. Never ending security push as we provide Lagoon to a lot of government customers, particularly in Australia and around the world. There's a never ending sort of circle of compliance and audit. So we're looking strongly at sort of rootless policies, how to apply network policies, more and more work in application image scanning to try and ensure the continual compliance of workloads running in Lagoon and on Kubernetes. That work in mass application management that we covered. So more work on facts, more work on intelligence, more work on automation. And our team will keep managing and maintaining Lagoon. We've got grand ideas about where we want to go and what we want to do with this. We do. So for people that, I'll put the links up to the GitHub organization, but there's a couple of GitHub orgs there, and we do operate sort of discussions, and we do have a lot of engagement with customers through those channels to find out what they're doing, whether they can help us, whether we can help them, and whether we're going in that right direction. So yeah, website lagoon.sh. Our Twitter handle is uselagoon. We've got some docs there. We're currently split across those 2 GitHub organizations. The Lagoon project itself is currently in Amaze.io, but will be in Use Lagoon in the next week or so. So it's very much a work in progress, moving that across. Thank you very much for listening.